My name is Brian Pohl. I am Epic Games Media and Entertainment Solutions Engineer for all of North America. And I'm sure you've seen a number of really technical presentations today. For my presentation, we're going to switch gears a little bit and go up to the 30,000-foot level and take a look at the big picture. We're going to be talking about pipelines and workflow. So I'd like to give you a little background on myself. I've been working in the film industry for about 17 years. Back in 1999, I moved out to Hollywood, California to learn a new software package called Maya. And it was supposed to revolutionize the animation industry. And frankly, I think it did. While I was out in California, I went back to school, and I found that I was in the right place at the right time. And I got a job up at Lucasfilm and at ILM working on the new Star Wars prequels as a previs artist. And I know what you're thinking, I had nothing to do with Jar Jar. So ultimately, previs became my career, and I went to work on dozens of different movies as kind of like a virtual cinematographer. And it served me really well. But today I'm on this new path, and I'm working for a completely different kind of company. So a game company, which kind of surprises me. And I'm transferring my film experience over to embracing the Unreal Engine. So as a solutions engineer, it's my goal to assist animation and visual effects companies integrate Unreal Engine into their pipelines. So I want to start off with a quote from my former boss, Mr. Lucas. All art is dependent on technology because it's a human endeavor. So whenever you're using charcoal on a wall or designing a proscenium arch, that's technology. So what was he trying to say here? Essentially, art pushes technology, and technology pushes art. The two go hand in hand, like a symbiotic relationship. And in just the past 5 years, we're seeing such a shift in technology that once again we're going to have to restructure our approach to animation and VFX for film production. So the next evolution of animation technology will unquestionably rely on being real-time, interactive, immersive, programmable, nonlinear, and viewer customizable. Our clients are already starting to take advantage of these capabilities, and we've got a few examples here. First off is Safari. This is a new animated episodic kids show that's being produced by Digital Dimensions right here in Montreal. And it will be released in France first in October, and then distributed in the US next year by Universal. We have Barbie Vlogger. This is being done by House of Moves in Los Angeles, and this is basically it's Mattel property, and it's a real-time Barbie variety show. And Barbie and her friends are taking questions from the audience and answering them in real time with an actor in a mocap suit feeding and streaming that mocap data into the engine and broadcasting this out live. And finally, some of my previous friends from Halon Entertainment were using the engine to create pre-visualization for War of the Planet of the Apes. And the new real-time technology is really helping directors in Hollywood, see their films being constructed before they actually have to go out and shoot them. And with the engine, it's even better because they can actually get a better sense of lighting, and the process is quicker. So this is all great, but today we're going to be talking about Fortnite. And for this presentation, we're going to take a snapshot in time to examine how the team at Epic Games constructed this particular trailer. So at Epic, we understand that creating animated content is not an easy task. So if we're to provide really excellent tools for our artists, there's an expression: we have to eat our own dog food. And in other words, we need to use Unreal Engine in production and try it out for ourselves. So we decided to create this trailer in order to learn all the benefits and challenges of creating an animated short in a real time. As a result, there's lots of progress being made. And some of those changes and advancements in technologies are making it into the engine in 4.16, 4.17, 4.18, and onward. But there's still a lot more to do. So after my presentation, there's another presentation that's going to be given about the roadmap of Unreal and what's coming up in the future, and it should be interesting. So for right now, let's get started, and we'll take a look at the trailer being run in the engine in real time.
All right, people. Let's search this dump and get out of here ASAP.
Dump? What's wrong with the Durburger?
Yeah, it's got everything. Garbage, rats, severe structural damage.
Some people just can't appreciate fine dining. Did you hear that? You got nothing to worry about. Trust me. I've got the heightened senses of a ninja.
Oh! I am so sorry.
Hey, it's okay. We're gonna get you out of here.
Oh, thank you. We thought you were more of those things.
Mom, monsters are coming.
Looks like we're staying put.
Right.
All right, you two stick with me.
Yes, ma'am.
Let's get to work. Okay, let's head to the roof for evac.
Aside from the part where we almost died, that was amazing.
Hey, don't mention it. It's all in a night's work. All right, guys, who's up for pizza?
Oh yeah, pizza!
I can't begin to tell you how many times I've heard that song. All right, let's see here. So let's talk about setting goals of what was expected for this particular trailer. In 2017, they started production for this trailer. It should be 3 minutes in length. It was essentially there to drive excitement and retention for the video game Fortnite. It's comprised of 6 sequences, 130 shots, and we were told, well, the team was told, it must be performant in real time at 24 frames per second. So that's basically a max render time of 41.6 milliseconds per 1/24th of a second. And for those of us who are coming from film, You should remember that number because that's going to become the new standard, the new 24 frames per second. Scheduling was reasonably aggressive. Production started around January of 2017 and finished in about 20 weeks. This was not including some time in late 2016 for some development and pre-production work. Throughout the production calendar, the team size ranged anywhere from a small 5 people all the way up to about 20 people, depending upon the workload. All of the character performance animation was outsourced to a company called Steamroller Studios in Florida, and I'm not exactly certain of their animation team size. The applications and formats that were utilized for this, well, Unreal, obviously, the game engine, but we have Maya for character animation, Max for modeling, Mobu for motion builder for motion capture, Premiere Pro for offline and final editing, and then we have some additional secondary programs, Substance Designer for materials, Blender for destructive simulations, Shotgun for production tracking, Perforce for version control, Olympic and FBX, of course, for the file formats, and Vicon Motion Systems was the motion capture system. So let's get underway and start talking and familiarizing ourselves with the 5 phases of production. Most people who are in creative industries, well, they're probably already familiar with this, whether you're in film, animation, or games. They are development, pre-production, production, post-production, and distribution. I list this as a traditional linear approach because these techniques were kind of developed, during the Industrial Revolution, and these, manufacturing industry concepts were applied to film production. And as a result, each phase of these 5 phases of production basically produces a product that has to be completed before it can be passed to the next stage. It's very assembly line driven. And this fit the technology of the time very beautifully, and it allowed Hollywood to churn out movies at a really incredible rate, during the golden age. There's some specific pros and cons with this linear approach. The pros are it's very formulaic, so therefore it's easy to establish a certain budgetary model for films. It's designed to spread work incrementally across different departments and work groups. And it had basically been the resource for driving the animation and film industry during the golden age. So the cons, of course, for this approach is it's very linear, highly departmentalized. That's also a bad thing. It's kind of has an archaic way of handling the version control of all the different products that they're producing. And it has a very slow revision process. It's difficult to schedule, and it's just generally slower. But ultimately, computerization and the advent of the visual effects industry would eventually change all of this. So today, we have a more modern outlook of the 5 phases of production. It's more of a nonlinear editing, the nonlinear editing processes and computer graphics fields and films like Jurassic Park essentially helped usher in a more interdependent 5 phases of production. So very quickly, we realized that the action taken in one phase of production could dramatically alter the preparations and execution of another phase. And this was really good, and it was really bad. It was really good because the entire production team started thinking of the film as a holistic entity, rather than just in an assembly line approach. But it was bad because the directors started to catch on to this CG technology and essentially started asking for whatever the hell they wanted. And the producers of the time were pretty much happy to go right along with it. And I'm sure all of you have heard kind of the saying, fix it in post, correct? This is practically Hollywood's mantra. And it wasn't until about the late 90s that the whole advent of doing pre-visualization was used to kind of help improve the blueprinting process during pre-production. So it helps reduce costly mistakes and control expectations of the director and so forth. So this model is still effective for today, but the artistic demands that we're seeing on technology keeps increasing, and something has to be done about all of the tighter schedules and smaller budgets that a lot of visual effects houses, animation studios, even game studios are having to address and face. So this brings me to methodologies. I want to do a comparison basically against the current model that's, I would call, traditional CG animation and approaches to how to pull this off versus a more next generation version of production using more real-time technologies and game engines. So there's a couple of different categories here. We have primary creative tools, developmental model, data and production, organization, version control, and so forth. Let's take a look between the two. Primary creative tool, we have the DCC, or the Digital Content Creation Package, like Maya or Max. That's commonly found in animation studios today. In a next-gen studio, it would be focused around real-time tools like a game engine. The developmental model, again, current model, it's a pull-based system. Each department in an animation studio has to produce a specific product that has to be finished or close to finished before it gets passed down to the next department so the next department can actually start work. In a next-gen system, it's more of an artist fetch data as needed, make individual changes, produce a change list, push it back up into the system, and it disseminates across the entire workflow. Data production and organization. Current model, it's very decentralized. All of your data is stored on various servers. It could be any number of different places, and the production organization is very departmentalized. Next-gen studio, highly centralized data organization. Typically, there's a depot of data that is stored where everything is being transferred to, and the production organization is designed to be more cooperative. Version control. Current model, if you're a small studio, it's typically manual version control with symbolic linking. And if you're a large studio and you're lucky, you've got scripts and people that can write different ways to handle the version control systems better. In a next-gen system, much more atomic transactions, ACID-based transactions for database handling, which makes it much more durable system and less prone to problems. Workflow, current model, less parallel, more parallel. And finally, I'm just going to talk about the output target. In a current model, essentially, all of the end product is working towards producing images and layers that can be assembled in a comping process and sent off to editorial. And it's very common in both animation and visual effects. In a next-gen model, it's more about, and this is what Epic kind of embraces, is a final pixel output philosophy. That's generally, we want to produce as much inside of the engine as possible and get those final pixels out from the engine directly to your audience. So whether that's being up on the silver screen, being web broadcasted, or broadcasted on air. So, knowing this, let's take a look at a typical animation studio pipeline. This is a modern pipeline, nonlinear. They have some very distinct stages that you will find in which there is a story department. It has that story department sometimes will work anywhere up from 6 months, 12 months to a year and a half producing story. They produce storyboards that are fed into editorial, which produce a story reel. That story reel is fed into the rough layout department. Meanwhile, also running kind of a little bit in parallel, you have an art department and a production designer who are basically feeding concept designs and sketches and such into the modeling department, the rigging department, and surfacing department. This all kind of happens as various concepts and designs are approved. So the end product out of the asset construction phase, along with the story reel, gets fed into the shot blocking process of rough layout and final layout. Rough layout basically creates the entire sequence comprised of multiple shots, and they're fed basically the story reel as a reference point. And as they complete shots in rough blocking, they replace the storyboard shots with a 3D blocking replacement. When we get over to animation, and after the sequence is completed with all of the individual shots in rough layout complete, it will go over to animation. The animation supervisor then, they start producing individual performance shots for each individual shot of the sequence, and it gets completed and eventually fed back into final layout, which massages the various cameras and so forth, and we move into a shot enhancement portion where we have stereo and crowds and character effects and potentially even a matte department. And ultimately, this end result gets pushed out into the lighting and rendering pipelines where final images, the scene is lit, it's rendered, and its images are spit out to go into the finalization process and editing and so forth. So this is kind of generally how it's done today. Before I get to the Fortnite animation pipeline, there's some things that you should understand that the Fortnite project had some specific advantages. Number one, and the biggest, of course, the Fortnite video game was being produced, right? So all of the game assets that were within that game IP could be pulled for use inside of the Fortnite trailer construction. So we had already pre-built models. We had game rigs. We had some game animations. We even had constructed scene assemblies for the different portions inside of the game. And all of this was used to feed into a pre-visualization process for Fortnite. The traditional CG process, well, they would have to construct all of this, and that could be months worth of work. So we had a huge head start. So let's take a look at the Fortnite pipeline. It's quite similar, but yet there are some differences. We didn't have a dedicated story department, but we did create storyboards. Storyboards were fed into editorial to produce a story reel. Sounds familiar, right? From there, our rough layout was essentially taking those game assets, combining it with motion capture, and doing a technique that in previs we call first unit previs. Essentially, that's the director working with live action actors inside of a mocap volume with a camera. And he can then interactively and intuitively and rather fluidly produce shots and block out the animation with real people. It's a tremendous difference in approach. It's a live action approach to animation as opposed to a more traditional resource where you're keyframing everything and you're having to use a rough layout unit to produce your previs, so to speak. All of the data that was constructed during this rough layout process was essentially routed into Sequencer, where we did a really rough, loose pass of creating level sequences. We kept it very loose and free so that we could create individual sequences and shots and so forth. It's actually eventually going to be a two-part process to this. I'll get to that in a second. I'll get to it right now. After everything was completed and our additional one-off shots were done, there was a refining stage or a re-indexing and conforming of all of the level sequences that were produced inside of Sequencer. And we're going to get to this all in more detail here shortly, but during this time, things are re-indexed, shots are officially created, sub-levels are defined, and all of this is being done as Sequencer. Essentially, Sequencer becomes the hub of production, whereas in the traditional system, editorial and layout is the hub of production. Step 4 essentially is there's an input-output process. All of the data that was created during this rough layout phase would have to go through an exporting process and sent to an asset enhancement phase where the game models may not have been exactly sufficient for a cinematic trailer, so they'd have to be up-resed and improved and so forth. So they would go through this. There would be additional rigging steps to improve the rig, And textures were resurfacing was necessary, etc., and it would be fed into into a Maya pipeline for animation, where keyframes would and keyframe performance would be done. All of this then would be routed back out of Maya and into Sequencer again, where we would start the process of final layout, lighting, effects, simulations, post effects, and so forth, and output for rendering. Now, each one of these steps we're going to go and get a little more detail in just a second. So what are the practical differences between these two approaches? Well, the current animation pipeline is a very front-loaded story process. Like I said, you have 18 months to kind of figure out your story. In a next-gen pipeline, it's a very integrated story process. A lot of people found that on Fortnite, the director had considerably more control to make suggestions in the entire process. In a current animation pipeline, shot construction is very deliberate. It is defined very early and upfront with the storyboarding process, which is, again, fed into rough layout. And by that time, you know what your shots are, period. The next-gen pipeline for Fortnite, it was much more of a live-action shot construction process. Like I was mentioning, the director actually could, on the day, make decisions. I mentioned this already, editorial and layout is the production hub of the current system. In the next-gen system, it's all about Sequencer. And then in the current system, after things are done in layout, well, it becomes a very team-governed system by the animation supervisors, the head of layout. All of these extra creatives are essentially taking over. The director starts to lose his creative influence. While in a next-gen pipeline, again, the director has, it's much more director-centric, and he's capable of making changes throughout the process. We'll talk about revisioning and revision systems in a couple of extra slides. So, story development. We're now going to get into the specifics. There were storyboards that were drawn up for Fortnite. They were used for initial ideas, and there were multiple concepts that were considered for this. All of the storyboards were essentially scanned and put into Premiere Pro, and there was a temp cut made and a story reel made that was essentially used as reference for the Mocap shoot. This is not too different from the traditional approach of creating an animatic or a boardomatic. So, next step. We're into this Mocap and previs session that we're having that we are calling rough layout. Not in the traditional sense, but essentially what we have here is we have a Vicon motion builder solution that was being used. The action was examined for logical breaks in the action, the progression and the location of where the animation was going to occur inside of the scene assembly. So the idea was, let's record as much motion capture as we can in large single takes as possible. And then we would review it and import it into the engine and validate it to make sure that everything was playing back fine and everything looked good. During this time, we're starting to basically block out what we thought were, what was best for the rough level sequence definition throughout this process. Again, very loose and free at this particular moment. And all of these takes and shots were assembled into one large, fat master level sequence. From there, basically, there may have been additional changes in the script or voiceovers. If that was the case, there would be one-off sessions with the director to capture those particular shots. And those were also added into this fat master level sequence. And once that was complete, that sequence was divided up accordingly into what would be defined as shots. And all the excess and deleted, all the excess footage in these duplicated level sequences was deleted so that it would be just the individual shot. Cameras were added in order to, with inside of the duplicated level sequences in order to help basically frame and obtain your screen direction and so forth. And by the time the individual shots were completed, in this rough phase, all the unnecessary actors and set pieces and such were basically removed from the camera's field of view that wasn't necessary in order to kind of like keep things simple. So this process, once it was complete, required a time of conforming all of this inside of Sequencer. So it's at this stage, that loose definition that we made, well, it's time to start getting serious. So all the rough level sequences that we made were organized into a more traditional sequence beat show structure that's commonly found in film. The level sequences were completely rebuilt to support this new configuration, and official shot numbers were assigned and re-indexed and assigned with inside of Sequencer, and also inputted into Shotgun for production tracking. It was at this point that Fortnite was branched off from Fortnite main. So we still were attached to the actual game, and it was at this point that we knew that it was time to create a separate fork in the road so that we wouldn't wind up making any destructive changes to what was happening on the game front. So with that, let me just show you quickly, just so you can see here. This is basically, we're inside of Sequencer here, and these are the 6 individual sequences that were created. There's the opening sequences, the DB sequence, and on through each. Each one of these sequences, when you enter inside, you can see that there is a nested, let me see here, there we go. These are the individual level sequences that make up the individual shots. And if you go inside of each individual shot, you can see that there is a number of folders that contain the specific characters and the scene assemblies and cameras and lightings for that single shot. Let's see here. Also, go back over here. All right, so we have all this data. It's now inside of the engine, and we have to start thinking about the animation process. So we have to get data out of the engine and into the Maya pipeline, because our animators are going to be working entirely inside of Maya. So for the various scene assemblies and environments, and even the characters, the game asset characters and their motion capture, was all exported out, unfortunately, manually, because at the time we did not have any specific tools that were designed to do this process for us. And these scene assemblies were brought into Maya so that the animators could have a reference for their performance. Restaging shots with additional rough layout usually was not required unless it was absolutely necessary. Our goal was to take what was specifically blocked out in our first unit previs or rough layout stage and go from there. So just a word quickly about version control. Epic, of course, uses Perforce with a customized wrapper that is known as Unreal GameSync. Unreal GameSync basically helps us track change lists and timestamps, all of the specific information and detail about each individual change that's being up. So this is how this process was utilized on the film, or excuse me, the trailer. And I also want to talk briefly about batch I/O. Again, I talked that this process at this time was highly manual. It was all we had. So we could do scripted batching and exporting out of Maya with Python. That was easiest. But everything else in Unreal Engine we had to do manually, and this was a major pain point. And I want to make note that Python is coming to Unreal. It is expected, at least last I was told, in 4.19. So for visual effects houses and for animation studios, this is a big major yes. So next thing I want to talk about is sub-level organization. So inside of Unreal, the CG supervisor, the director, they wanted to make sure that everybody could possibly work on this show in a parallel fashion. So they created a series of sub-levels in order to organize the labor by specific discipline and ultimately to control scene assembly visibility and character visibility and a number of other factors. So we have some specific sub-levels that are created. Of course, we have a persistent level, which is the virtual scene container of all of the sub-levels. And inside of that, there is environmental sub-levels for the various scene assemblies. I'll show you some of those in just a second. There's a character sub-level where all of the FBX bodies for the characters would reside, and we'll get to that. There were sub-levels for the various sequences or the cine sequences. For each beat, there was lighting sublevels, blueprint sublevels, and a post-processing sublevel for doing post-processing effects after the fact. Let's see here. If we go, just a minute. So, just to show you here, the sublevels were designed, to have specific visibility cues that would be override on an individual, set up for each individual sequence and potentially changed inside of each individual shot. So for this particular case, you can see some of the properties and which levels are visible and which ones are not, depending upon where you are inside of the sequencer. So here we have specific visible sublevels, dB Cine, dB lighting. This is specific for the dB sequence, the lighting exterior, etc. So this process was essentially a way to help organize, control visibility, and allow a more specific means to work in parallel. All right. Okay, so while we're preparing for our for the animators to have a reference for blocking, there's also a stage that's happening in parallel in which we're enhancing all of the game assets. So the Fortnite characters, the game assets were good. Some of them were usable with inside of the trailer. Most were not. Several were not. And the idea was that they had to be enhanced. So these game asset characters were brought over, and they were brought into Max, and all of the heads and bodies were separated. The models and textures were then augmented with additional resolution and extra topology where needed. Any of the baked lighting was then stripped out of the assets texture maps because, as you've heard in the last presentation, Fortnite used a dynamic lighting setup, so there was going to be no baked lighting, and we'll explain why in just a minute. And all the facial geometries implemented a universalized topology so that we could exchange data between characters and have shared expressions and so forth. The character rigging, all the game rigs, they too had to be enhanced. So characters inside of Maya now were re-rigged with the Art version 2.0 tools inside of Maya. Additional leaf nodes were added for anim physics. Good way to supply secondary animation for free. And the entire facial rig was rebuilt with new controllers and additional joints in order to improve facial appearance. So let's talk briefly about this whole FBX and Alembic cache workflow. The body for each individual character would be an FBX. And each body for each hero character, which was our 4 primary Fortnite characters, the mother and the child, had an average of about 55,000 polygons or 110,000 triangles. Each Alembic head was on average 35,000 polygons to 70,000 triangles. Again, a universalized topology. And so each character would basically add up to approximately 185,000 triangles per hero character. So if we were to look at this, you have the individual FBX body and the head. So it's kind of funny. A lot of times for a number of the scenes, you see a lot of people walking around without heads. But in the breakdown for each individual shot, the bodies of the characters would be referenced into the shot, while the heads, the Olympic caches, were spawned on an individual shot basis. All right. Let's see here. Okay. So let's take a look at the original game rig. Here is our lovely soldier here. This is a 26 facial joint game rig. It looks pretty good. You get some decent expressions. However, the face and the structure looks harder, sharper. And there's a specific limitation with FBX's implementation in Unreal. You can only have 8 influences per vertex using FBX in Unreal. So this gave us some limited deformation capability. The improved cinematic facial rig and improved topology on the faces upped the number of joints to 201 joints for the facial rig. And this rig was combined, or it was a combination of joints, blend shapes, and lattices, and basically taking advantage of all of the animation and deformation capabilities inside of Maya. And ultimately, this deforming mesh, it removes that whole influence limitation with FBX. So this Olympic cache for each head, for each shot, would be exported and converted to GPU morphs inside of Unreal Engine and blended and streamed out of memory in real time. So here's an example of what that looks like. You can see it's much more fluid, it's much more expressive, the face looks softer, and very expressive. Animation inside of Maya. All performance animation was outsourced to Steamroller Studios in Eustis, Florida. Steamroller, they utilized their own asset and production management pipeline to produce and track all of the data. As Steamroller completed the individual animation for each shot, it would be uploaded to Box, where it was downloaded by the Epic animation team and tweaked where necessary, and then integrated into Unreal. All Maya files at Epic were then tracked through Perforce to ensure version control. This was tricky because you had an FBX body, you had an Olympic head, and you had various props that the characters were carrying. All facial performance was keyframed and exported as an Olympic cache. Body performances, again, utilize a combination of game assets, mocap, and keyframing, exported as FBX. Prop animation was keyframed and exported as FBX. And all destructive simulations were actually done in Blender and exported as an Olympic cache. Material matching for Olympic, just to touch on that. The materials would need to match between Maya and what would be in Unreal. And you would assign your textures and materials to the actual faces of the geometry, not just the overall mesh. And then all characters inside of Maya was primarily using quads. So it had to be triangulated into a mesh and exported out as an Olympic cache, where the ABC file was then imported as a skeletal mesh inside of Unreal, and again, converted to PCA compressed morph targets. And I was told, make sure to tell them, use GPU for morph targets needs to be turned on when you're importing this. So I want to note that there is a YouTube stream that was just released on the 21st by Tim Hobson and Sam Dieter, which gives you an excellent overview of the Olympic pipeline on a step-by-step basis. It's a great demo, so take a look for that online, and you can learn more about this process. All right, out of animation, we're now back in the engine, and we are doing final layout and scene polishing. So we've got to there usually was no need for additional restaging of shots unless it was absolutely necessary. And if it was, That animation changes could be done inside of Maya, then brought back into the engine. All camera animation constructed inside of Unreal Engine. And let's see here. I've already mentioned that. Character animation performances would, if it was required to be changed, would return to Maya, make the changes, and then brought back into Unreal. Lighting, briefly on this. There was a system of light rigs that were used for some sequences, and other sequences used spawnable lights. Generally, the team found that light rigs was the preferred methodology. However, spawnable lights worked as well. Both were performant. Lighting priorities were utilized to alter the light planning on an individual shot basis. So you could have a light plan for the overall sequence, and then when you got into the individual shots, you could override that light plan and make changes specifically for the shot. The choice of lighting was dynamic lighting over baked lighting, mainly for the benefit of the director. When you're trying to do creative control and you're trying to make things look good, baked lighting, though, when optimized, probably gave better performance. It was just taking too long to make the changes that the director and cinematographer may have wanted, and so they chose to go with dynamic lighting instead. Distant field ambient occlusion was connected to the various base materials of objects in the scene, providing a soft shadowing effect for anything in the scene that was being hit with non-shadow producing lights. And then they also utilized PCSS soft shadows on dynamic lights and spots to give a nice soft shadow appearance with the lowest overhead possible. Effects and post-processing. This is I want to point out, if you did not get the chance to see the SIGGRAPH live presentation online, please check it out, because Ryan Brooks gave an extremely much more detailed description of this entire process. But essentially, real-time Navier strokes fluid simulations were used to do all the 3D volumetric storm clouds and fog, and I'm just going to leave it at that. I would highly suggest that you take a look at the YouTube presentation. It goes over all of the processes of creating the fog and the deaths of the husks and how they would appear once they were struck by bullets or whatever. So let's see. I also want to mention that I stated that there was a post-processing sub-level that would also allow you to implement the tone mapper capabilities inside of Unreal. And they use this to do color correction inside of the sequences and shots as necessary. And this is kind of interesting because this whole process lets you control with the tone mapper the entire look and feel of the general appearance of your final outputted pixels. So the guys at the team here, they went and created an interesting little extra. We'll just stay in sequencer here, or excuse me, we'll go in engine and let's see. Actually, sorry. Escape. I want to also do this. They did an interesting little variation of the Fortnite trailer to do kind of a film noir look. So we go black and white, have a little vignetting, and do some work on the audio. And even cooler, put in some theremin.
All right, people. Let's search this dump and get out of here ASAP.
Dump? What's wrong with the dirt burger?
Yeah, it's got everything. Garbage, rats, severe structural damage.
I'm also going to
Some people
customize
just
the
can't
appearance of the
appreciate fine
ninja here
dining.
in just a second.
Did you hear that?
You got nothing to worry about.
Now he's got his white
Trust
uniform
me.
on.
I've got the
He's
heightened
carrying a
senses of
lightsaber.
ninja.
So I want to point this out, just that, using post-processing effects, you can make immediate changes to your project, especially if you're going live, to customize your final output on an as-needed basis, which is, I think, pretty cool. So I know I'm running out of time. All right, so final output. All the shots were rendered out of Sequencer as image sequences. Those image sequences were brought into Premiere Pro for final editing. The conforming process between editorial and Sequencer is still something that leaves much to be desired. Unreal does have support for EDLs, but this process was definitely a manual conforming process to make sure that there was parity between what was being seen in editorial versus what was currently inside of Sequencer. But there's a lot of discussions right now, and part of my interaction with animation and visual effects houses is to improve this process. So, okay, that basically wraps up the pipeline. And I guess if we have questions, we can go from there. Yes? Yes?
Hey, to what extent was sound design implemented in the production process on the trailer using Sequencer?
It's my understanding that most of, like in a traditional process, there was a recording process of the characters' voiceovers. I believe most of the sound design was handled through the more of a traditional editorial process than with Sequencer, but all the tracks were recorded and inserted into Sequencer to help with performance blocking and timing purposes. I'd have to get you more information for that, but good question.
Okay, thanks.
Yep. Questions over here?
I have another audio question.
Oh, great.
When the the audio engine will be kind of actually out and can be used in Sequencer or more in-game, besides using the sound visualization plugin.
So what specifically is your question?
I guess when the audio engine will come out and how it will actually be utilized.
I can't give you an answer for that one. I'm unaware. I will check with my tech guys, though, and see if I can get you an answer after the show.
Okay.
Yes?
I was just wondering, did you have an actual, so you mentioned about look that were added. Was actually Sequencer used to completely control the color grading process of the entire trailer, or was there a more classical path like you did with Premiere Pro, for example?
The desire was to keep everything within the engine and utilize the tone mapper capabilities in the engine to make modifications and changes to any type of color on a shot-by-shot basis.
So it was purely a tone mapper that was used systematically on a shot-by-shot basis?
That's my understanding.
Thank you.
Question in the back.
Hey,
Hello?
that was a great talk, very inspiring. I founded a studio basically a couple years ago on the idea that the future of animation was going to be real time. So it's great to see this process reflected in the adjustment of the pipeline. I'm wondering if you guys, I know this is Fortnite, but if you guys have thought about or have done any experiments in Unreal with ARKit or AR Core, and how you see the pipeline changing, or the idea of this pipeline changing with augmented reality and virtual reality.
Wow. Definitely. As part of the enterprise team, it's kind of our goal to handle all non-game interactions with our clients. So ARKit, AR Core, augmented reality, huge, big thing. I was just looking at some today in one of our meetings in which I was able to look at different pieces of furniture inside of an iPad, and you've seen some of the other examples. I would say, for the future of this, definitely. The idea of being able to utilize augmented reality as a storytelling device it's intriguing, it's different, it's, I would say, what would be accepted or expected within the next 3 to 5 years, especially as the technology continues to get better and we get decent glasses that can make this lightweight and portable and simpler to use. But yes, I would say you will definitely see the story process embrace that medium. Another question here.
So if I understand correctly, you had a process where you exported everything that was in Sequencer to Premiere, and you did editorial refinement. I'm not entirely sure I understand why that was required. And the corollary question is, how does Sequencer deal with actually generating media that is suitable for an editorial package? In other words, fully unique ID, time-stamped correctly with time code, frame rate management, all of that stuff.
All of that is definitely something that has to be addressed. There's, again, at this particular stage, it was all about just simply outputting image sequence files outside or out of Sequencer, out of Unreal, and imported into Premiere Pro. The whole relationship between, conforming between Premiere Pro and with Sequencer was, at this stage, manual at best. That's definitely something that I've heard from a number of different clients, requesting that kind of functionality to be able to have a level of parity between Sequencer and an external editorial package. Trust me, that's something that we know about and are planning to address. So to answer your other question, the idea of still allowing an actual film editor to have his hands and his eyeballs on the content is still of great value. So, until we get editors who are fully proficient inside of using Unreal and using Sequencer for doing editing, that may be a little bit difficult. So the whole idea here was to provide the footage to editorial in order to have them work their magic, so to speak.
So it is more a question of skills as opposed to a question of functionality.
Well, it's a bit of both, actually. So, you've got to have editors who are familiar with this kind of technology, and being able to put this all together. Plus, we're clearly missing some key tool sets to allow parity between the two.
Thank you.
To point on that, it would be really great, even in the earlier stages when you're doing storyboarding and creating a story reel that ultimately would be brought in and followed as a guideline. Much in the same way of a traditional pipeline, it'd be nice to have something in reference where if the editor makes changes, even as early as the story reel, that it would update Sequencer. And likewise, if you made changes in Sequencer, it would inform editorial. That's hugely crucial.